Okay, let's crack on then. So hi everyone, my name's Tim. I'm from the employee and branding team at Just Eat Takeaway. Hi to everyone watching either now or later. Just to mention, so Martin's going to give his talk, and then later on we'll have a Q&A session. So if you can leave any questions until that section, that would be really helpful. If there's any issues, technical or otherwise, then you can put them in the chat. And then when we come to the Q&A, how we'll work it is if you raise your hand, and then I have the function to unmute you from our side, so Martin can hear your voice, and we'll work it that way. And if there's any problems with internet, so the sound isn't that clear, then we'll also use the chat function for the Q&A. So without any further ado, Martin, I'll hand over to you.
Hi everyone, welcome to the talk. Let me just share my screen. And then Zoom moves all the windows. So just get them back so I can see what I'm doing. Don't usually use Zoom. Just bear with me a second. Cool, right. So hi everyone, I'm Martin Costello. I'm a principal engineer here at justeattakeaway.com, and I'm also a Microsoft MVP in developer technologies. And the talk I'm going to give today is about what's new for minimal APIs in ASP.NET Core 7. So I'm going to give a brief sort of intro into how we use .NET here at justeattakeaway.com, and then a quick overview of what's new in ASP.NET Core 7 as a whole. Then I'll drill into the new features in minimal APIs. Then I have a little tangent on new things coming from minimal APIs that are affecting not just minimal APIs. So they have some effects towards ASP.NET Core MVC. And then we'll have a small focus on a new feature that isn't specific to minimal APIs, but that based on how minimal APIs has been changed for this release, you can hook that unrelated new functionality into minimal APIs with little extra effort. So what about .NET at Jet? So at Just Eat, we've been using C# and ASP.NET since the company was founded in 2001, which was quite a long time ago now. I was still doing my GCSEs when that started, so it's quite a long time ago. And also in the Just Eat part of the business, we've been using .NET Core since version 1.0 in 2016. We've benefited from many things of .NET Core over ASP.NET with traditional .NET framework. Like it's a lot easier to test, so it makes us a lot more productive. It runs cross-platform, so we have developers that can work on our production services on their MacBooks instead of, say, a Windows computer, which back in the day with .NET Framework was just not a possibility unless you maybe were really sort of out on the edge and tried to use it with Mono, but that had lots of missing features. Another big benefit we get from .NET Core is the focus on performance. With all of the investments going into .NET Core in terms of not just new features, but in refactoring, changes to the just-in-time runtime, to the garbage collector, all the other bits that are part of .NET that aren't just bits of code you type, mean that we get actual monetary savings to how much it costs us to run our platform from running .NET Core, because it's so much more performant than what came before. For example, on this slide here, there's two graphs from a blog post I wrote a few years ago when we adopted .NET Core 2.1. And you can see on the left graph, like the previous week before we did the update, the response times were higher and a lot spikier. And then after we did the update to ASP.NET Core 2.1, they came down quite a bit and also were fairly consistent and stable and not so spiky anymore. And then on the second graph, you can see how this translates into sort of our real world costs. This is the auto scaling group of an application that was upgraded. And through the improvements to the performance, that meant, as well as the improved response times and consistency for our end users and our customers, this also meant that when our auto scaling rule kicks in to like add more instances to the group to scale up, that happens a lot later, which is the green line, which translates into less cost for Amazon instances to run that application. We've also been doing lots of testing with pre-releases with .NET Core, particularly since 3.0. We're also keen early adopters. We have an internal working group where we sort of look at the new versions before they reach their sort of 0.0 version for a particular release, and as well as sort of helping prepare our internal applications to be ready to move to new versions and pick up the latest and greatest improvements and enhancements. But it also helps the wider .NET community because it gives more eyes on the product, and it means we can give feedback to Microsoft if we find any issues or rough edges in proposed new functionality. And in the case of .NET 6, we started to run that in our production environments, starting with release candidate 1. And with the release of .NET 7 this year, we're actually already running some workloads in production on .NET 7 since RC1, which is the first release of .NET 7 that Microsoft will support using in production. We wait until that point to start using it in anger, rather than using previews because they aren't supported if something breaks. So just to give a quick sort of overview of like the numbers of how we use it internally. So we typically have two types of applications internally, and for .NET at least, we either use AWS Lambda to run Lambda functions, or we use EC2 or EKS to run more like application code as a service for compute. And we have just a few more Lambdas versus EC2 EKS. So it's just about a 50-50 split if you squint and ignore them, do some rounding. In the case of Lambda, we use, this is the number of applications running .NET, not functions, because we might have related suites of functions that belong to a single application. So this isn't the number of functions, this is the number of applications which have one or more Lambda functions. And typically we're trying to migrate our compute functionality over to EKS or Lambda and removing usage of EC2. And in terms of which versions of .NET we target, so we still have about 18% of our applications running on .NET Framework. These are typically older applications that we're looking to replace with something new rather than upgrade in place. Just over a quarter running .NET Core 3.1, about half running .NET Core 6, which is the current LTS release of .NET. And then we have a handful of applications already running .NET 7 in our production environments. So, but what's new in ASP.NET Core 7 itself? So, as I just mentioned, ASP.NET Core 6 is the current long-term service release, and ASP.NET Core 7 is going to be the next major release, and that's going to be what's now known as a short-term servicing release. So that means it will be supported for 18 months, whereas an LTS release is typically supported for 3 years. So if you are looking to upgrade to .NET 7 and use some of the new features we're going to go through today, just bear in mind that you're going to need to upgrade to .NET 8 by mid-2024, when that goes out of support once .NET 8 replaces .NET 6 as the latest LTS. So things coming to ASP.NET Core 7, the main thrust of this talk is going to be on the new extensions and functionality for minimal APIs. There's also new functionality to make rate limiting for an application a first-class citizen of ASP.NET Core. Typically, you had to implement that yourself or using community libraries such as ASP.NET Core rate limit middleware or Poly, but now there's first-class support built in. Similarly, they're also now adding output caching to ASP.NET Core 7, and there is a whole slew of functionality built into that. I did consider including it in this talk, but there's so much new functionality in output caching, it just wouldn't fit. But that's a very big investment area for new features. Also, HTTP 3 will be supported in ASP.NET Core 7, whereas in ASP.NET Core 6, it was a preview feature, so you had to opt in to use it, and there was a possibility of breaking changes that might have occurred. And another final two features that are part of the theme for ASP.NET Core 7 are support for gRPC JSON transcoding, which is the ability to present gRPC services through to JSON functionality you might already have that makes it easier to benefit from gRPC on top of existing functionality you might have that's based on JSON. And there's also a additional side project, I've forgotten the name off the top of my head, that's you can use to help migrate from ASP.NET to ASP.NET Core. It provides shims to allow you to easily migrate existing code to the new world with all its breaking changes by making the old code cross-compile for .NET Framework and ASP.NET Core, so you can like slowly move functionality from a quote-unquote legacy website into a new website using technologies like YARP. And I'll share a link to the slides after the talk, but there's a link to the GitHub issue here, which is the roadmap for ASP.NET Core that has more details on all the different things that are part of this release. So now we get on to minimal APIs itself. So what I'm going to do is I'm just going to go through different new features that are being added with little code snippets here, and I'll just talk through them. And at the end of the talk, there'll be a link shared to a GitHub repo that contains all of the code for these examples, and you'll be able to clone that yourself and run it and play around with it if you so wish. So the first piece of functionality I'm going to talk about is what's called a root group. So a root group is a new construct in minimal APIs that lets you group together different endpoints in a minimal API. And that then allows you to sort of configure common functionality that applies to all of the endpoints associated with that group, rather than the ASP.NET Core 6 way, where if you wanted every endpoint to require authentication within a minimal API subset, rather than configuring it globally in the whole application, you would have to configure that on every endpoint and remember to do so. Whereas with a root group, you can apply all of that functionality at the group level, and it will apply to all of the endpoints you define on the group. So here we have our endpoint root builder, and we're going to map a group to it. And a root group takes a string as a URL, path prefix for the group. So here the group, all the endpoints are going to be prefixed with API/users. And then we can require authorization on every single endpoint associated with that group. And we can also name the group, which is useful for things like Open API and other metadata. So now we have our root group. We can just configure endpoints on those like we would without a root group. So, but here, because this is part of a group, even though we're saying that this post endpoint here just has the apex path of the application, is the application root, because it's part of a group, its URL will be API users, but I don't have to repeat myself with all of the individual endpoints on this group. They all just inherit that. So the get and the post will both be API users. So that's for me to create a user, say to get all my users. But then if I want to get a specific user, I can just put /ID for the root parameter from the URL. And then that will be API users ID. And then similarly for the delete operation here. And because these are all part of the group on which I've required authorization, these will all inherit the requirement to need authorization for these API endpoints to be used by a client. So another new piece of functionality is what's called endpoint filters. So endpoint filters allow you to wrap a minimal API endpoint with some arbitrary behaviors, or potentially to even intercept or change the result of a minimal API endpoint based on some business requirements you might have. So one example might be you might want to add some metrics around all your endpoints. Say every time someone requests an endpoint, you might want to emit a observability metric to time how long that took. So with a endpoint filter, you could wrap every single one of your minimal API endpoints with an endpoint filter, and then just run some arbitrary code before the endpoint is invoked to start a timer, and then at the end stop it and report a metric. So as an example here, I've just got an inline Lambda which is an endpoint filter. And I'm just going to use this to sort of add some logging just to demonstrate how things work. So I've got a Lambda function here, which just logs a message when it's executed. And then I can add on an endpoint filter to it, which logs something here. And then this endpoint filter is passed a mouthful of a type name endpoint filter invocation context that contains all of the root parameters and the HTTP context. And then similar to how middlewares work, there's a next parameter, which is a delegate, which is of type endpoint filter delegate. And that can be passed the endpoint filter invocation context again, and will return an I result. So in this example here, I can log a message before I execute the handler. Then I can call the next delegate and pass it the context. And that will do whatever is configured in that pipeline. So it might be that it just calls the endpoint itself directly, or it might be that it calls another endpoint filter if there's multiples configured, because you can have any number of endpoint filters added onto an endpoint. And then it returns a result. And in this case, I'm just logging something again and then returning the result back up the HTTP pipeline. But if I wanted to, I could say inspect the HTTP context, sorry, not the HTTP context, the endpoint invocation context, and then I might actually not execute the next delegate at all. I might do something else, which there's an example of later in the slides. Or I might inspect the result and decide to decorate it or change it or do something else based on whatever my business requirements might be. So in this example, if it were to be run, so we've just got a little bit of logging here to the console from running the sample. And you can see here it prints before, during, and after. So if you just go back a slide, so because it doesn't flow in the order you read the code. So in this case, the filter's been run, it's logging the before, it's calling the next delegate that will come through into the Lambda here and log the during. And then once that's returned, it will log the after and then return that to the HTTP pipeline. So you can kind of think of an endpoint filter a bit like an onion, and it sort of layers and goes in and back out again, similar to how middlewares work. In the previous example, that was an inline Lambda function for the endpoint filter, but you can also use classes to implement endpoint filters if that's how you would like to implement your code, or if the code you want to be a filter is very complicated, in quotes. So you don't want it all in line in like a really long Lambda function. So instead, what you can do is there's an interface new in this release called iEndpointFilter, and you can implement that interface on a class. That has the same signature as the inline delegate that we saw before. So it takes the context and then the delegate that's next. So the implementation here is exactly the same from a functional point of view, but it is implemented as a class. The class isn't in of itself registered with the dependency injection system, but it works in a similar way. So you can declare parameters on the constructor of your endpoint filter, and they'll be resolved automatically for you from runtime from the dependency injection container. So in the case of this endpoint, I can just say add an endpoint filter of my endpoint filter, and that will be instantiated for me at runtime and run the appropriate code at the appropriate time. Another new piece of functionality that's now supported is file uploads. In the previous release, when minimal APIs was new, there was various sort of special types that weren't from the path of the request or the headers or the root or from the dependency injection container, but they were like, quote, magic types that the runtime knew about specifically that could be injected as parameters for minimal API endpoints, just to make things easier for you as an engineer to write some code, such as the HTTP request or the HTTP context or the claims principle for the current user. So in this release, they've now also added iForm file. So if you have a URL encoded form, say on a web page, and you want that to be backed with a minimal API endpoint, instead of having to read all of the content out of the HTTP context manually, like get the request, get the form, read the files. Instead, you can now just use iForm file as a parameter, and the request delegate factory infrastructure for minimal APIs will just bind that automatically for you and pass it into the method. So in this example method here, we have a form that's a form file as part of a HTTP form that's just called blob. And using DI, we can inject an S3 client for AWS, and then we can just open the blob and then put a file into an S3 bucket with minimal overhead and without having to worry too much about trying to parse and read out of the request the actual contents of that file. It doesn't just work with one file, it works with multiple files. So this is effectively the same as the previous example, but with an optional second file. So if that's submitted and it's not null because it's nullable, so it's optional, then we can put 2 files from our uploaded form into S3 in this example. But if you don't know how many files you're going to get, or there's multiple files, or you don't know the names, you can also inject as a parameter the iForm file collection and then just iterate over the files and do similar functionality like that. The main reason that wasn't included in ASP.NET Core 6 is there were some concerns about the possibility of cross-site request forgery with requests for form posts and them not necessarily being protected and potentially creating a security vulnerability depending on how the application works. But with the addition of endpoint filters, it's now actually quite trivial to protect such endpoints with minimal code, so that if you did have functionality where that might be a concern for CSRF, then you can implement something like we have in this example to protect against that. So the minimal API endpoint here is identical to the first iForm file example, but it's got this extra call here for validate anti-forgery. And what this does here is this is an extension method that extends iEndpoint convention builder. And what that does is add an endpoint filter that runs before like the next delegate is called. So in this case, it would run before the actual business logic to upload the file to S3. And what that does is it just gets the anti-forgery services out of the HTTP context and then validates the request. So that's checking like the headers or the cookies against the form post and checking that it's associated with the current user context. And then if that succeeds, then it just calls the next delegate and would then run the code for the endpoint itself to upload the file. But if an exception was thrown because the anti-forgery validation failed, then in that case, you can just return a result and say it was a bad request. So you could write a fairly simple endpoint filter and then just apply that to all your endpoints or all of your root group. And then you can sort of have your cross-cutting concern of protecting anti-forgery issues on your form file uploads by just applying an endpoint filter to any such endpoint. Following on in a sort of related piece of things you might do in your business logic, in ASP.NET Core 7, minimal APIs now also support binding to the raw request body. So if you're not submitting, say, a JSON object or an XML object or something that you can get parsed down into a POCO, and you just want to look at the actual raw bytes on the wire, it's now possible to bind that directly to either a stream parameter or a pipe reader parameter. So in this example here, we have a parameter stream called blob, and that's bound directly to the HTTP request body. So it doesn't matter what format it's in. It could be binary, it could be text, it could be JSON, it could be XML. It doesn't really matter what the content is because you're just getting the raw stream of that. And then you can deal with that progressively. So effectively, the client can stream the application body to you and you don't have to read it immediately. And so in the case of if you had like a very large request, I don't know, maybe dozens, hundreds of megabytes, maybe it was like a file upload service, you don't have to balance the difference between, I'd like all the simple code programming constructs where you just give me objects and I operate on them. because in a case of hundreds of megabytes, you would have to buffer all of that to parse it and give you an object that would represent it. Whereas if you didn't want to buffer it, you'd have to consume the HTTP context or request directly and then manually read through the stream. So this is sort of the best of both worlds, and it will just give you direct access to the stream. And then you can stream the content from the client request body as you see fit for your business logic, which in this case would just be streaming a file from the client up into an S3 bucket. And then similarly, that also works with pipe reader. The example here, I'm just going, it's a pipe reader, you would use it. I've not written any code to actually do the equivalent of consuming the pipe reader. But if you had some custom business logic where you had a binary file format and you might want to chunk it up or do different parts with it and things like that, then that makes such functionality a lot easier, as you don't have to have the HTTP request or context and then sort of step through the properties to get to the reader. You can just have the reader directly pushed into your code. And then to sort of flip that on its head and go the other way around, it's now also possible to stream to the client with minimal APIs. So for example, if a user wanted to download a file and you have that file in an S3 bucket, you don't want to have to download the whole file, particularly if it's very large, all the way into your application and buffer it just to then send it back onto the client, because maybe your business logic's just doing some authorization logic and is otherwise not operating on the content. As it was before, unless you wrote all the code to do this in the right way yourself manually, you would effectively have to buffer all the content out of the stream, in this example from an S3 bucket, into your application and any memory, CPU, IO overhead that had, and then just pass it immediately onto the client. But now with the new results stream response method, what you can do here is you can just lazily assign this so that you don't actually have to go and get the blob until it's needed in this example. So this method would return immediately with the result.stream return object, which would be an iResult for dealing with the stream. But it wouldn't actually call through into this Lambda method to actually return the stream of the blob you were trying to stream to the client until the HTTP request actually needed to start sending the bytes down to the user. So it wouldn't actually connect to S3 and start reading the file until after the HTTP headers had been sent to the client and the client actually wanted to read the body, rather than you having to buffer it all up front and then maybe the client just reads the headers and then never reads the body. But you've still then done all the work. In such a scenario now, is you would never even connect to S3 yet if they dropped off after getting the headers and didn't read the body at all. Another new feature in terms of parameter binding is the ability to bind to collections. So if you have a query string parameter or some HTTP headers that can contain multiple values, you can now have those be bound into either a string values, which is sort of the raw struct type that is used on the HTTP request object for headers and query strings. And you can get all those values in one object, have them do whatever it is you would like to do with them. But if you don't want to use string values itself, you can also just bind an array itself and just pay for the additional allocation of the string array. And as these aren't, in this example, these aren't decorated with a from attribute, so these would just be bound to a query string parameter of name. But if you wanted to read from the HTTP headers, then you can just decorate it with the from header attribute, which was already in version 6 for minimal APIs. And then you can just, so if you've got a user agent that's made out of multiple values, as you might often see if you're trying to use user agent sniffing, say a request from a browser, then you can just access all of the values in the string values single parameter itself, rather than having to manually try and parse out all the different values out of the query string. Sort of tangentially related to that is a new concept called argument lists. Argument lists can be used to bind multiple different parameters into a single parameter new request. So for instance, if you say had a endpoint that had like 10 different query strings parameters that it could possibly go to it, say something to do searching or paging or what have you, you might find it a bit cumbersome to have 10 parameters on your minimal API endpoint, because you would write, especially if you say you're writing unit tests or something like that, that's like lots of parameters to pass in where you might only need 1 or 2 of them. So what you can do to support argument lists is you can use this new attribute as parameters. So in this example here, we have a endpoint that we use to search for some users in a hypothetical system. I can create a struct, or sorry, a record struct. It could be just a normal record. It could be a structure, whatever it is that is most appropriate for you. But in this case, it's a record struct. And all of the constructor parameters for that, which generate the properties, these will be implicitly bound onto the query string of the HTTP request. So if I've got a query string parameter called ID, it will get bound to this ID property, email, name, date of birth, etc. So instead of me having to have 4 extra parameters on my endpoint here, I can just have the 1 and declare it as parameters, and the normal binding rules for parameters on the minimal API endpoint will apply to it. So they'll all be sort of nested down into that object. The nesting only works to 1 level, so you can't have as parameters of as parameters of as parameters, etc. It just works down to 1 level. And in this case, because there's no from attributes, these are all from query string. But if I wanted to, I could use any of the from attributes here and add them onto this find users request object, and it would just bind them in the same way. So if something was from services or from headers or from body, you can use them in the same way and consolidate everything into a single object. And if you use a record struct, that's sort of the lowest allocation way to do that and the most performant. So another fairly large change that's been made to minimal APIs based on user feedback is the introduction of these new typed result classes. So one piece of feedback that some users had with minimal APIs was that because the results class, every method on it, such as results.stream, returned an iResult, everything looked the same. And then that made it, after the fact, in sort of a introspection way, difficult to actually see what was going on for the different requests. And similarly, it also made unit testing more difficult to do for minimal APIs if that's something you wanted to do. So there's a new two new things of interest here. The first one is this new typed results class. So instead of using results.badRequest, you can now use typed results.badRequest, and the difference there is the type that's returned from the method. So instead of every method on typed results returning an iResult, it instead returns a concrete type that's appropriate to the operation you're performing. So in this case, it returns a bad request result. And then in the case of created, it's like a created result. So each one creates a different type. So then that gives you like a concrete type to do things with the results if you wish to. But that creates a new problem, which is if you wanted your result to be iResult, you could do that because everything implements iResult. That's all fine. But if you would have to cast everything to an iResult before returning, because otherwise the compiler would complain that your return types didn't match. So the way they've solved that issue with how this design works is there's this new results generic type, and this can take between 2 and 6 parameters, but you could extend it to more if you really needed to. And what you do for each type parameter, you use the results that are being returned from the type results class. So actually it's called created and bad request. I got the type name wrong just there. And the results of T class has methods on it to do implicit conversions between a concrete type and iResult. So this allows some interesting behavior that we'll see in a minute. But in the immediate term, just by having the return type explicitly declared here instead of iResult as a results created bad request. That means I don't need to do the cast on my returns here, and the code's just nicer to read. So the benefit of using that, which I missed a bit, which is that all of these new type results implement this new static endpoint metadata provider interface, which we'll come to in a bit. And what that allows the framework to do is when you use things such as Swashbuckle for open API specifications, it allows it to automatically infer the different HTTP response codes and result types that come out of your application endpoints. So here on the open API endpoint for the previous example, it's just implicitly documenting the fact it returns a 201 and a 400 without that having to be explicitly added as endpoint metadata, other than the fact that we use the results of T as the return type. Another new feature here is, which again builds on top of C#11 static interfaces, is binding by convention. So there's a new interface called iBindable from HTTP context. And what this allows you to do is define a static method on a custom type you might have that allows the binding infrastructure for minimal APIs to turn the HTTP request into the type that you would rather use as the parameters into your endpoint, rather than say having to do manual parsing in the endpoint for something it didn't know how to do. And the power of this is because it uses the new static interfaces, it means it doesn't need an instance of your custom type to be able to bind it, because if it doesn't know how to bind it, it can't make the objects, then you wouldn't be able to implement the interface to call it to do the binding. So with static interfaces, this means the framework can just invoke your code and know it's going to get a result of the appropriate type as you've defined however you parse it, and then pass that to the endpoint method. So in this example here, we have an endpoint that takes a geolocation, which is a custom type. And then if there's no geolocation, returns bad request, otherwise calls some business logic and returns a result in a HTTP 200. So we have our custom record class geolocation here, which has a latitude and a longitude. And we can implement iBindable from HTTP context on it with the geolocation. The framework will then at runtime call the bind async method on it, passing to it the parameter that the association we're going to bind for our endpoint to it. So you can say, look at the name and the type, and give you the HTTP context. So in this case, what we do is we just have some custom code that looks at the location query string parameter. If it's not found, then we didn't create an instance of a geolocation. If we did find it, then we can split it, because in this example, the value of the query string parameter is expected to be two numbers separated with a comma. And then we can split it. If there's the right number of components and they both parse to a double, then we can return our parsed latitude longitude value as our custom geolocation type, which then gets passed to our endpoint, and our business logic can just operate on the geolocation. So with all of these typed result classes, this also means that another thing that was feedback was that it was difficult to unit test minimal APIs. Like if you use a sort of a black box approach to your tests, some people might call them integration tests, some people might call them system tests, then changing from say MVC to minimal APIs wasn't much of a big deal from a testability point of view, because you would hope that you would already have all your tests that tested your application that used MVC as a black box. So if you just change all the implementation details internally to use minimal APIs, all your tests should still pass. But if you had unit tests, then you can't really unit test minimal APIs, because everything comes back as an iResult eventually. And then that requires quite a lot of code gymnastics in your assertion methods to sort of unwrap the results, see if they're the right type, the right values, etc. So with the use of typed results, that makes it a lot easier to unit test minimal API endpoints if that's something you want to do. So in this example here, we have like two endpoints that add and multiply integers, and they're implemented not as lambdas, but as independent methods in a static class. So they can be called just as code. And in this case, they're using type results JSON, which means that because they add 2 integers and return an integer, or the product of 2 integers, they return a JSON HTTP result of type T, so an integer in this case. So then that means it's pretty trivial to write some unit tests for these 2 methods, because we can just hook them up as a standard XUnit test with like a theory or a fact, and just call maths.add with our X and Y and get our JSON HTTP result of int, and then assert that the value returned from adding or multiplying the numbers is what we expect, without having to use an integration or system level test of the HTTP sort of protocol itself. We can just do it in code. And another small change, which is nice, is simplification of authentication. So previously we had like the require authorization endpoint, which meant that an endpoint you would need the user to be logged in to be able to access it. But if you wanted to be more fine-grained, you would have to use authorization policies with attributes and define those in various places, and then rely on that to be a bit more imperative. What you can do instead in ASP.NET Core 7 is there's new overloads of require authorization that allow you to configure the authorization requirements on individual endpoints or on root groups. So in this case, we not only require the user to be logged in and authenticated in some way, but we can also require them to have a specific claim. So in this case, we say, oh, the user must have a scope claim with a value of admin to be able to access this endpoint. There are other things in addition to require claim, such as the username and specific role functionality that can also be used, but it just makes it a lot more compact and inline and easier to sort of grok when you're looking at code if it's all implemented inline here, rather than having to apply attributes with authorization policies onto the lambdas and things like that. And then the final bit I have specifically on OpenAPI, not OpenAPI, minimal APIs, is there's also been improvements to the way you can decorate endpoints for your OpenAPI and Swagger documentation. So we've got 2 examples here. In the first example, we can use these new with summary, with description, or with tags attributes to add OpenAPI summary descriptions and tags to an endpoint or an endpoint group, so that things are appropriately decorated when we get our OpenAPI JSON or YAML specifications, rather than having to write custom code and custom endpoint metadata to add these things to the endpoint. And another new functionality built on top of that is like, if you really need to go custom and there's lots of different things you want to do that you can't just do out of the box, then there's sort of a new emergency break glass method called with OpenAPI, which is part of the new Microsoft ASP.NET Core OpenAPI NuGet package. And that will give you access to the low-level operation on the Swagger, on the OpenAPI documentation. And then you can just change the properties as you see fit. So you could run custom. So with the summary, you can only run as much code as you can at the point of calling with summary. But here you could inspect the entire operation and say dynamically change the summary based on something, or generate maybe example responses and things like that. So with the new with OpenAPI message, you get access to the full OpenAPI endpoint that you want to document, and you've got access to all of the properties of the underlying infrastructure used to populate information in libraries such as Swagger. So that's all the new things that I was going to cover in Minimal APIs itself, but there's also some new features that have come from Minimal APIs into other parts of ASP.NET Core. So like they can, if you're not using Minimal APIs, you might be able to use things that have come from Minimal APIs in existing code you already have. So I've only got 2 examples of this for this talk, but there's 2 new features that have come to MVC that have been directly influenced out of Minimal APIs. So the first one is that there's now implicit service resolution. So it used to be on API controllers that If you wanted to have a parameter that was resolved from the dependency injection container, you would have to decorate it with the from services attribute. But in ASP.NET Core 7, you can omit the attribute, and the runtime will see if, in this case, my service is a service that's resolvable by the IOC container. And if it is, it will just implicitly resolve that for you and pass you the value. So if you were using from services for some MVC controller actions previously in ASP.NET Core 7, you could just delete those attributes and it will still work. And then another thing that's come through from the minimal APIs world is MVC can now implicitly convert the HTTP request parameters into custom objects if they implement either iParsable, which is a new static interface from C#11, or if they just have a try-parse method that conforms to the usual shape of try-parse. So taking a string, having an out parameter of the type you're trying to parse into and returning a Boolean that's true or false. So in this case, if I've got a custom struct called name that takes a value, if I have a from query parameter of an MVC action method that takes a name, it will automatically take the name query string parameter string and pass that through to my parse or try-parse method. If you have both, I can't remember the order, which one it prefers. It's probably try-parse. And then it will just return my name object as I've defined in my code, which is just return the object. There's nothing special going on here. But then it means in my action that I can just take a name and use it rather than have to do all the parsing myself or just take the raw string value of name out of the HTTP request. So the last bit I just want to touch on is rate limiting. So rate limiting is new functionality that's built into ASP.NET Core. It's in the shared framework, so you don't need any extra NuGet packages to use it. It's just there for you to use if you wish to. And in this case, I'm just going to demonstrate its use of the middleware. So there's a new use rate limiter middleware you can add at the appropriate point in your pipeline, and then that will wrap all the requests within that middleware pipeline with a rate limiter. And there are two types of rate limiting built in. There's a token bucket based rate limiting, so it's like a rolling window, or there's like a sliding window based implementation that's just simple timing. It's like you can have 100 requests a minute, and then when the minute's up, it will reset rather than like a rotating set of usage. So to configure it, I can say what status code to return if something is rate limited. So in this case, I want to use 429. I can have a global rate limiter that applies to everything, which should be on the next slide. Or you can have specific rate limiters for specific operations if you want to, using policies. And then you can declare what to do if something is rate limited. So in this case, I'm creating a rate limiter here. This is being created dynamically at runtime based on a request. So what I can do is, if the request's not authenticated, I can have a no-op. Sorry, I can have a no-op rate limit. So if I'm not logged in, I can just say it's associated with an anonymous user and it's not rate limited. But then I could look at the HTTP request otherwise and have like a read rate limit policy and a write rate limit policy. And then I could access my configuration to configure a rate limit as I would like to based on some requirements. So in this case here, we're sharding a rate limit based on our operation, which is read or write, and then our user ID. So we're sharding our rate limits per user. So one bad user, if they use up their rate limits, it doesn't use up the resources of your server for all the other users. It just affects sort of your resource hog. And in this example here, we're going to use the token bucket limiter. So I can use my configuration. I can configure things sort of how often the tokens in the bucket are replenished, what the queue limit is, whether it's oldest or newest first requests are processed, what the limit is, how many tokens there are per period of time, and how often tokens are replenished. So when something is rate limited, you get access to an rejected context. which you can then inspect to decide what it is you want to do when someone's been rate limited. So in this case, I can look at the metadata of the lease of my rate limit, and I can extract the retry after metadata. So the framework knows how often I have requests, how often I can make requests and what my limits are. So if I violate them, it can tell me how long it is until that particular user, whichever rate limit policy it was you were going to use, will be able to try again. So I can extract that value and then use it to build my response up. So this is where I can hook it into minimal APIs. Through the extensions property on the results class, I can write my own rate limited iResult and then execute that to return a response. So I'm taking the metadata out of the rate limit here to get the retry after value. And then I can pass that through to my own custom extension method to create a rate limited result with the retry after value. So then I can implement my own iResult, take the retry after value, and then use that to execute my request to return the response and return a HTTP 429 to the client to say they were rate limited. And then to circle back to something I mentioned earlier with the iEndpoint metadata provider, the new static interface, if I implement that interface on my rate limit result class, I can add additional metadata that tells the framework that my endpoint returns HTTP 429 responses. So that means that if I were to document this endpoint with OpenAPI, it automatically adds HTTP 429 to many request as a possible response to all of the endpoints that I decorate this result with. So I just get that extra sort of introspection into my OpenAPI documents out of using that new interface as well and plugging it into the rate limiting infrastructure. So that's everything specific I was going to talk through today. ASP.NET Core 7 is currently at release candidate 2, which is the final release candidate. And the final release will be next month and will launch at .NET Conf, which is on the 8th of November. There's some links here. I'll get these, a link to this put up in the talk when things are over, so people can get access to this and look at everything if they wish to. So there'll be a link to the sample code, a link to ASP.NET Core itself, where you can look at any issues and pull requests for things related to ASP.NET Core 7 or give feedback, raise issues. There's a link to register for .NET Conf if you wanted to attend that. A link to the latest blog post about what's new in ASP.NET Core 7 for RC2. Link to the .NET blog for all the blog posts that the .NET team publish. They regularly publish from preview to preview throughout the year about new features and new functionality that might be coming. And another link to the roadmap. Also like to mention justeattakeaway.com, we are hiring. We have several open positions available. So if you like the idea of working on the latest versions of .NET in business logic and getting paid to do so, then check out our careers website at careers.justeattakeaway.com. And there's also a link to the open positions in technology that you can take a look at. If after this talk you'd like to contact me, don't know why you would, maybe you do, maybe you don't, maybe you've got questions, or maybe you just don't want to talk to me, who knows. Anyway, if you'd like to talk to me on Twitter, you can reach me at Martin_Costello. If you'd like to look for the repository of the samples for this talk or any other open source activity I do, you can find me on GitHub at Martin Costello. And there's also a link to my LinkedIn. That's it from me. So thank you everyone for coming to the talk today and listening to me talk about what's new in ASP.NET Core 7 for minimal APIs. So I'll hand it over to Tim now to help wrangle any questions anyone might have.
Thanks, Martin. Yeah, so for anyone who was late or anyone who's forgotten, because we're on Zoom, how we're going to work it is if there are any questions, if you raise your hand, then I have the ability to click a button that says allow to talk. So we'll do it via the medium of audio. Just a reminder, as Martin's alluded to, if there's anybody, colleagues of Jet, we do have some external people watching. So if you want to discuss any company secrets, then please do so on Slack. So if anyone's got a question, just use the raise your hand function. I'll keep a look on the chat. and yeah, unmute you essentially. Until then, we'll wait in awkward silence. It can often happen that the talk is so good that nobody has any questions about it at all. Okay, Daniela, I will allow you to talk. Oh, Daniela, did you want to? Yeah, I'm going to allow you. Here we go.
Hello.
Hey, Danielle.
Yeah, I just think it would be interesting if you could share what issues we found when we were doing the early adopters testing.
Yes, that's a good point. Yeah, so for anyone external, yeah, as I mentioned at the start, we're running an internal early adopters group, and over the last 10 months of all the different previews, like we found different issues here and there. So yeah, once the 7.00 release comes out, yeah, I'm going to look at sharing out another version of the blog post I did for ASP.NET Core 6 of the various issues we found along the way.
Anybody else? I'll also add a link to the main tech logins as well to your slides before I send them out, Martin. Anybody else with any questions? Oh, Stuart, I've seen you. Here we go. Go for it.
Hey. I was wondering if there's any, so you got the endpoint filter.
Yes.
Is that any more powerful than middleware? Is it just like a convenience? Because I suppose you could always like add your own metadata and add a middleware, but that was a bit cumbersome. Is there any more kind of like power you get from that model?
So I guess it depends exactly what you're doing. Like the main thing it gives you over middleware is on the, I forget the full name, the endpoint blah, blah, blah context. It gives you access to the root parameters. So they'll all be pre-bound. And I think you also get access to the endpoint metadata. So if you were to do that with the middleware, you would have to jump through the hoops to get those yourself for a minimal API context. Whereas if you use the endpoint filter, you just get given them. And also it's the results. So if you're just doing something like timing, there's not much in it because you're just running some arbitrary code before calling some other code. But in terms of extra features, so you have the endpoint metadata and the root parameters, but the main PowerPoint of it actually, which is what I sort of said first, is that you can operate on the results. So say, for example, if you had an endpoints where if a certain condition was returned for every HTTP endpoint, you returned a custom object. And then based on that custom object, you might want to do something else. In your endpoint filter code, what you could do something like, if result is my fancy custom type, then you could do an if block and operate on that specific type, and then you could like mutate the result object directly. Whereas if you were doing that in a middleware, if the response had already started to be written into the body of the request, then it would be too late to do anything like that. So I think that's the main feature, is it sort of, if it's giving you a point in the sort of the high level APIs before it gets down to the HTTP processing pipeline to sort of do fancy custom stuff if you need to.
Got it. Yeah, nice one. Yeah, thanks.
Thanks, Stuart. We are at time, but if anyone's got one more question, I don't know if you've got time, Martin. But
yeah, I can do one more if there's any.
Yeah, if there's anyone, one more. Brave soul. But if not, that's also okay.
Maybe everyone's just sick of listening to me.
Okay, yeah, we'll leave it there. Thank you so much, Martin, for the talk, and thank you everyone who watched. And like Martin said, we will send out the slides internally and also on meetup.com for everyone who wants to have another look at them and check out all the links that Martin shared. So thanks very much for watching. Thanks to Martin. Have a nice day, everyone.
Yep, thanks for attending, everyone, and thanks, Tim, for running the session.
You're welcome.